Hello, everyone. Welcome to our new session. Today, we have a very special guest with us, Natesh. Hey, Natesh, would you like to go ahead, introduce yourself, and let us know what we are going to learn new today in this session?
Sure, Kaivalya. Yep. Let me first share my screen. Yeah. Is my screen visible?
Yes, it's visible.
Okay, perfect. Hey, all. Thanks again for being here today. And today's topic is going to be careers in data science. And I am Natesh Babu Arunachalam, and I'm going to be spending the next 1 hour with you, going over this topic. To start off with, I want to briefly introduce myself. I currently work for Mastercard USA as a director of data science, and I'm leading a team that is building payment experiences using AI/ML technology. And as I'm working, I'm also a part-time MBA student at UC Berkeley. And previously, I had my master's in undergrad in engineering. And I've been fortunate to be a part of like few different organizations in my career so far. Currently, I'm at Mastercard, as I mentioned. Previously, I was with JP Morgan in New York, building out their risk modeling products for like fraud detection, underwriting models, marketing, targeting, etc. And in India, I got a chance to spend some time at Swiggy, where I was part of the team that launched Hyderabad back in 2015, and also some time in Oracle. So that's a little bit about me. And in today's agenda, I want to cover a few different topics. The first one is why data science, right? Like, why should we even focus on careers in data science? And next, I would like to define the field. What is data science? Data science is a very broad term with many different definitions, which is often confusing. So I would like to spend some time defining the field and then talk a little bit about what are the skills required, how to become a data scientist, and end with Q&A. So that's my plan for today. And with that, the first question I want to post to this group, I hope to keep it very interactive. So the first question I have here is, I know all of you here have signed in to learn about careers in data science. So any volunteer here who would like to chat about why does he or she want to pursue data science? Any takers? Okay, we definitely need more energy for the session. So I'm going to go ahead now, but I would definitely call upon people after a few slides. So, we definitely need the energy.
We have like a response in the chats. It says very trending.
Okay. Hey, Keshav, great answer. Can you elaborate?
Yeah, so hi. So what I went when I said very trending, it's basically, every now and then in my like Chrome feed, I am getting like, this AI model discovered, this LLM is there, that LLM is there, new technique has arrived, protein folding is happening, and everything, all the base of it is just data science in itself, right? So that is like everything now that is happening in the current few months only. I am seeing that there is like a sudden acceleration in this field. So I think this is a very good time to jump in.
Got it. Yeah, I think that's true, Keshav. Yeah, definitely this year has been very interesting, and we'll see, like why that is the case, right? And thanks for volunteering. So I want to encapsulate this question of why data science in a couple of charts. The first chart I wanted to share here was about the number of S&P 500 companies that cite the word AI on their earnings calls. So what this means is companies, especially S&P 500 companies, have like quarterly earnings calls where they talk to their investors and analysts. And over the last few months, as Keshav probably rightly pointed out, in the second quarter of 2023, almost 40% of S&P 500 companies have mentioned or used the word AI in their earnings calls. And if you see just 5 years back, this number was probably like 46, less than 10%. So it has grown fourfold in 5 years, which does not happen in a lot of fields. Hopefully, this gives you enough motivation to, explore the field and, take some learning in the field. This also means that this technology AI is not only restricted to a particular industry or sector, but is broadly applicable to a variety of industries and firms. Now, let's talk a little bit about what is the financial impact of AI, right? So we saw companies are talking about AI, but does it actually turn into anything meaningful, right? So here we have a follow-up slide where we see the valuation change or the stock returns for companies that use the word AI. The bar chart on the left shows price change from June 30th. And the chart that you see in dark blue is of companies that cite AI, and the light blue is companies that don't. So we see that in a turbulent market environment, companies that cite AI have fallen less, close to 1% versus 2.3% for other companies. And from beginning of the year, companies that cite AI have actually given a return of 13.3%, whereas companies that do not cite AI have only given a return of 1.5%, which is a 10% difference. Again, a very, very significant difference. So not only does AI get talked about often, this also results in meaningful price changes or stock performance returns to investors and stakeholders. So it's definitely a very valuable field to be in. And the other motivation as a data scientist working in industry is how is the jobs going to be, right? Like, what is the salary? Do I get paid to do this job? So based on statistics, which I gathered both in US and India, it does seem to be the case. In 2022, the median pay for data scientists in US was more than $100,000, which is more than double the median salary in the US. So definitely great earning potential. And the job outlook over the next 10 years is also fantastic, with an expected growth rate of 35%, which is much faster than the average industry. And on the right, I have the numbers or the salary numbers in India, which also shows the case that data scientists do end up making a quite significant earning potential in India as well. So definitely universally true statement where there's a lot of potential for this job in both India and US and in other countries as well, I'm sure. And with that, we have briefly seen why data science is valuable and what is the potential of it. Now let's talk a little bit about what is data science. In my mind, a data scientist is someone who can transform raw data into actionable insights and create value. This is a very loaded statement and can oftentimes be confusing. So I took a picture which I really like, which encapsulates the statement very well. So we start off with data, and this is explained using Legos, which helps the case further. So we start off with data, which is basically a jumbled mess of Lego blocks of different colors, not very useful. And then we sort them. We sort them by color, which kind of is a step in the right direction, which makes it a little more useful. And then we arrange it based on colors, which is another step towards being useful. And then we present it visually when we stack the Legos based on colors. And the next step is we explain it with a story. So far we have seen like a very jumbled mess of Lego blocks. Then we sorted it, arranged it, presented it visually. And next is to explain it with a story. So here we see that we take the same Lego blocks and try to build a house out of it, which looks a lot more beautiful than a jumbled mess of Legos, I'm sure we all agree. And the last step, which is the most important in my view, is to take the messy data and make it actionable or useful. So a beautiful house is really cool, but again, it does not have any utility. But instead, we can take it to the next level and build something out of it. Let's say we build a toothbrush holder or a spoon rest or a keychain holder. Here we see that the data is actually taken from a messy block and actually made useful and actionable, which is what the end goal should be for anyone who's a data scientist. And if you notice here, I've specifically underlined these two words called creating value. This is something that is often lost as we think about data science, where we think about the core models, the technologies, the mathematics, the statistics, and all that. But I think the most important aspect here is to create value. Because without creating value, it's not going to be a popular and a useful field. So in that note, what is creating value? So here I've given examples of two projects, Project A, Project B. And we have two options, option A and option B, of how we talk about the project. So for Project A, Let's say we built an XGBoost classifier and we increase the accuracy of XGBoost classifier to 95%. And option B of presenting project A is transaction fraud went down by 5 times and saving multi-million dollars for the company. And for project B, option A is build a new recommendation engine using TensorFlow. Very, very important. But option B is the cart abandonment rates went down by 20%, thereby increasing revenue by X percentage. So again, I need volunteers at this stage who can tell me which of these two options are better and why. Like, which of these two options are a better way of projecting the work of project A and project B? So in this case specifically, I think most of us fall prey to saying option A, because as data scientists, we like to be in the technical realm of projects. But I strongly believe that option B is the way which actually has a better impact. And that is the way we can actually portray creating value. Because option A is something that maybe your technical counterparts may care about, but option B is something that is actually going to be important and is going to be more valued when you're a data scientist. Or in other words, in my mind, option A talks about the action, whereas option B actually talks about the impact. And creating value is a synonym for creating impact. Now let's talk a little bit about what are the different kinds of roles in data science. Now, data science is very broad, very confusing, and is a very broad umbrella which is often misused by different firms who define the role differently. It does not help anybody that data science job descriptions are so confusing and expect different skills from different people. So I found this very good infographic which talks about the types of data scientists in different organizations. The first one is the vertical experts. So these are people who have a lots of experience in a particular domain and are valuable for that specific skill set that they bring. For example, there could be someone who's an expert on insurance or an expert on protein folding, for example. And they would be called as the vertical experts. And next we have the star DS managers. These are people whose primary job is to manage a team and make sure that they're high performing and deliver outcomes on time to stakeholders. The next type of data scientists are dabblers. So dabblers are people who do not do data science full time, but they could be in adjacent roles or allied roles. For example, they could be data analysts, or they could be software engineers who spend, say, 20% of their time dabbling in data science. The next type is ML engineer. Again, it's very adjacent and often confused with data science, but ML engineers specifically bring an engineering dimension to data science. They are professionals trained on writing production level code, deploying models, and taking a data science product end to end. The next type are generalists. These are one of the most common you can think of the generalists as Swiss Army knives. They can do a lot of things, or you can also think of them as, jack of all trades. So they can do multiple things, but they might not be a specialist in one particular thing. They are very useful for industries or jobs where the tasks and work streams keep changing quite often. The next type are legends. So these are people who have been doing data science or so-called data science for more than 10, 15, 20 years. And they have specializations in programming languages like C, C++, which predated Python. And they have been in the field for more than, like a lot of time. And even before data science became quote unquote cool. And the last type is statisticians. So these are people who come to data science from a more mathematical background. Like they could be like PhDs or, experts on statistical modeling techniques, for example. And this pretty much, in my experience, sums up the different kind of data scientists you typically come across in an industrial setting. And the two most common, in my experience, have been the vertical experts. So this could be examples of people who have spent their entire career, let's say in JP Morgan. Like I used to work with people who have spent like 10, 15, 20 years in the same firm, looking at the same kinds of data sets and so on. And generalists who are typically, new graduates or, early career data scientists who are entering the field and are trying to figure out their interests. So these would be, the most common types of data scientists you would come across in industries. Next, I would like to touch upon what is the overlap between roles. So following up from the previous slide, there are again 4 different types of roles which are often confused with each other. Data engineers, data analysts, data scientists, and ML engineers. Again, you would see a lot of job descriptions for each of these roles having a lot of the same technologies, which makes it even more confusing. But I felt that this radar chart actually puts across the point really well. If you're a data engineer, you're focused on specifically on building data pipelines, making sure you have the databases up and ready, and focusing on data tools, or in other words, data infrastructure. If you're a data analyst, you're focused more on storytelling, data visualization, business insights, metrics, and reporting. So basically, taking the data and creating insights out of the data. And if you're a data scientist, you do more of the hardcore statistical and machine learning modeling, you do inference, statistical inference, you do experimentation, hypothesis testing, a lot of those stuff. And if you're an ML engineer, specifically focused on model deployment, ML ops. And of course, as you would naturally be observing, there is a lot of overlap at the core. It's not like if you're a data scientist, you don't need to know data visualization, for example. You definitely need to stretch across the different dimensions. And each of these dimensions are going to be different based on the industry also, for example. If you're a data scientist in technology industry, let's say if you're working for Google or Facebook or any of the big tech, a lot of your data science work is going to be mostly on storytelling, data visualization, and experimentation. A lot of product-based companies focus a lot on experimentation. Like if I change the color of this button, what happens to the product metrics? Do the number of purchases and orders go up, go down, etc. So whereas in a bank, if you're a data scientist, you're heavily focused on the stats and ML modeling and less so on experimentation. I'm just going to pause here for 30 seconds in case people have any questions. Next, I would like to go over the data science pyramid of growth. So this is kind of like a mental framework that I put together to think about the field. So we saw in the previous slide that there are many roles with allied skill sets and capabilities. And how do you succeed as a data scientist? What are the levels to data science? And that's kind of what I want to encapsulate in this slide. The bottom rung or the foundation of this pyramid is machine learning. You cannot get into data science, or it'll be very hard to get into data science or become a data scientist without strong foundations in like ML models, for example. You really need to know your classification models, your regression models, natural language, computer vision. So you need to really be fluent in different kinds of modeling techniques. Along with it, it'll also help to know other data science techniques, which are becoming even more popular, such as explainability, statistics, definitely some familiarity with the cloud, data visualization, etc. So these are almost a must-have. These are like table stakes to even, enter the field. As and when you enter the field and you start gaining more experience as a data scientist, you would need to layer that up with engineering skills. And the reason I'm saying that you need to have engineering skills on top of your data science skills is the reason is it makes you more valuable. It makes you more critical for your firm, and it also makes you a full stack data scientist. It reduces your dependency on other teams to actually, take your work and do stuff with it. So what I mean by engineering is if you build on your skills for, say, deploying ML models, learning technologies such as Docker, get or making sure you're writing good unit testing and production ready code. These are going to definitely increase your value in the team. And finally, the business skills. These are very important as and when you become from a senior data scientist or a junior data scientist to a lead data scientist, manager, director, etc. So the business skills come to the forefront at that stage. And it's not a bad idea to start building those business skills right from the beginning. What I mean by business skills are thinking about the success metrics from a product perspective, thinking about the domain knowledge that you need to have to build that particular product, industry trends, looking at what your competitors are doing, looking at economic trends and trying to bake that into your product development process. And finally, also your customer interactions. Sometimes there's a good opportunity where if you're in a big company, you get a chance to work with customers and figure out their pain points and bring that back to your product building process, which is again very helpful. So business skills are definitely a cherry on the top and will help you stand out from the crowd. These are going to make sure that data scientists who are often thought of as just technical rock stars can also speak the language of business and become successful as data scientists. Next, let's look at what are the hard skills for data science. So this was from a survey data of skills, which was found in like per number of job descriptions. So we see that Python was found in more than 50% of job descriptions. Again, expected, not surprising. Next one is Excel. Again, Excel, it was surprising to me to see that Excel is a top popular skill for data scientists. But it also made sense given the fact that a lot of data science is also data exploration, data analysis, which a lot of it which is done in Excel. The next skill is SQL. Again, very important for querying data, and almost it's a very popular topic in like data science interviews, etc. Next one is Spark. Very important for distributed data processing, and even more important today when most companies are generating petabytes of data every day. And the next one is AWS. Again, cloud technology, very popular. A lot of our workloads and code, etc., is being done in the cloud these days. It could be AWS, Azure, GCP, any of these things. But I think it's also a very important skill to have to make sure that you stand out as a data scientist. And there are a bunch of other skills. The only other thing which kind of, I in my mind is important for an early career data scientist in this list is also Tableau for visualizing data sets. But I strongly feel that if there is someone who can become fluent in the top 5 skills here, they have a really good chance of making a good career in data science. For example, it could be Python, Excel, SQL, Spark, and AWS, which makes someone like a well-rounded data scientist to begin their career. And next, I would like to talk about the soft skills for data science. So in the previous slide, we looked at the hard skills for data science. Now, I would like to look at the soft skills for data science. Although I've put them as soft skills, I truly believe that these are actually the harder ones between the two and are definitely not easy to gain. But amongst the soft skills for data science, number one would be dealing with ambiguity. This is very important because in data science, a lot of times we do not have clear guidance. So you could be asked by your product stakeholder or your manager, this could be like a actual statement of what you might be asked, which is to do an analysis to evaluate how the product metrics change when we tweak this feature. Very confusing, very open-ended. And the words that I specifically highlighted here is to do an analysis. Again, what type of analysis? Not clear. Is it cross-sectional, panel data? Not clear. What do you mean when the product metrics change? Increase, decrease, by how much? By 5%, by 10%? Not clear. And what does tweaking a feature mean? Again, very open-ended. So this is a true type of task you might be asked to do as a data scientist, which you need to approach scientifically, breaking it down, making your own hypothesis, and trying to validate those hypotheses. So definitely being comfortable with ambiguity is like a top skill to have as a data scientist. The next one is to have very, very strong communication skills. And I specifically called out both written and oral. And this is important because data science involves working with a lot of people, and it's important to communicate effectively. And in fact, as an anecdote, back in my job with JP Morgan, one of the skills which was required in the job description was actually strong communication, which actually made its way to the job description. A next soft skill is stakeholder management. How do you work with people from different backgrounds is also important, because as a data scientist, your typical stakeholders could include a multitude of people. You could have stakeholders from engineering, a product owner who could be your scrum master, a product manager, and someone from strategy or compliance, and also senior leadership for sure. You need to be able to translate the work that you do into different languages so you're able to communicate with all of these people. Like if you're going to tell that you're building an XGBoost model, highly likely that a product manager is not even going to understand what you're talking. So you need to make sure that you're communicating effectively with people from different kinds of backgrounds. And the next one is to own the outcome. This is especially important because this helps to make sure that a data scientist is trustworthy and is able to do a task and is reliable. What this means is if somebody owns the outcome in my team, I'm able to give a complex task to that person. They are able to run with it, complete the task, and come back within the time that is promised. And the last one, again, very important, is to keep learning and be adaptable to change. This could sound very generic, and I'm sure it does, but this is exceptionally important for our field where things keep changing every day. Especially you would have realized with 2023 earlier in the year when we had ChatGPT, this entire year has been the year of LLMs and language models. For example, some of the stuff that I got a chance to learn about this week was, RAGs or retrieval augmented generation, which is becoming very popular, and also GPT-4 Turbo, which was launched a couple of days back. So all of these things are probably changing at a weekly cadence, which makes it almost a necessity that we keep learning and be adaptable to change. Now, let's talk a little bit about the kind of tasks that you would do as a data scientist. And this was again from a survey which surveyed a bunch of data scientists and other data professionals to see what type of tasks that they were doing. So the tasks that are listed here are gathering data, cleaning data, visualizing data, building model, running model, and analyzing data. And if you sum up all of these, the data-related tasks, you would see that close to 60% or slightly more than 60% of time is actually spent in the data step. Although your title says you're a data scientist, a lot of time you're actually spending looking at the data, which is actually very important for you to do any of your other tasks, such as building a model or building a product. And you would see that there is a little bit of variation for different titles, like that of a data scientist, you see a little bit of a variation. And if you're a research scientist, you're probably spending more amount of time actually building a model and a little bit of lesser time on cleaning data. And research scientists, again, a very specific title which are given in specific industries. For example, in technology companies, they're very popular to give research scientist titles where you're focusing more on doing R&D. And next, I would like to chat a little bit about what are the pathways to data science, right? Or how do we get there? We spoke about why should someone do data science? We spoke about what is data science. We spoke a little bit about what are the roles in data science. Now let's see what are the ways to become a data scientist. And I've broken down into the 3 E's. The first E that I can think of is education. Your degrees, your certifications, and your courses, online courses, for example, your MOOCs. And Andrew Ng, of course, I'm sure all of us here would have heard of him. And he was the reason I got started in the field, and I still recommend his course, Introduction to Machine Learning, which still stands the test of time. The next E is exposure. This could be doing Kaggle projects. Again, it's a wonderful resource. You have a bunch of data sets across different functions. Like if you want to do a biology project, you can do a biology project. If you want to do a fintech project, you can do a fintech project, and so on. You also have notebooks and solutions by top data scientists across the world. It's the best place to get started. You can also participate in hackathons like MLH or other hackathons. You can attend conferences or meetups where you get exposed to people doing different kinds of data science. You can do coffee chats with people in the field to learn more about how industry is working, what they're doing in the industry, and hopefully getting a job, a referral, etc. The last one I have in the exposure dimension is to read company blogs. A lot of companies these days are actually very open about what they do in data science. Like some of the companies that I follow include DoorDash, Uber, Swiggy has a really good technical blog where they talk about the kind of data science that they do. And I'm sure that there are multiple other companies which have fantastic blogs to follow. And the last E here is experience. So you can also become a data scientist if you're working in a slightly different field where a lot of skills are transferable. For example, you could be a data analyst where your data analysis skills and your data wrangling skills could be very helpful as to be a data scientist. You could be a BI engineer and bring your business skills to data science. You could be a software engineer and morph into like an MLE or MLE/DS. You could also be a product manager. There have been many product managers who have also made the switch to data science, surprisingly, where they bring a lot of the product knowledge and the technical skills, or they upskill themselves to become a data scientist. So I would say you could also become a data scientist by pursuing education, getting exposure, or experience. I would say at least two out of three E's are kind of mandatory to become a data scientist. You definitely need to have, like I would say, the education or the exposure, if not the experience. If it's going to be your first job, you definitely need to have something in the education column and something in the exposure column to get you started in the field. And next, I think this has been a very successful strategy for me, which is to keep it simple. And this is especially, again, important in data science because things get complicated very soon. And I think the more we strive to keep things simple, the easier we can separate the signal from the noise. And these are some of my favorite quotes to keep me following this ideology. So one is from Albert Einstein, who basically said that genius is making complex ideas simple and not making simple ideas complex, which is very true. And one from George Box, who was a British statistician, who said that all models are wrong, but some are useful. The second sets the context to non-technical people that machine learning is very much a science. There is also a lot of art component to it. Nothing is guaranteed. And most of the models that we build for machine learning will be wrong. But just because they are wrong does not mean they're not useful. Like, for example, a lot of the weather forecasting apps or science behind it may not be 100% accurate, but does not mean that we do not rely on weather forecasting. And the last graph that or the plot that I have here is to talk about, which is a tweet, which talks about how do you go about ML strategy or ML model building. This is a tongue-in-cheek tweet, which basically says that when you have a problem, you build two solutions. A very complex solution, which is, for example, a deep Bayesian transformer running on multi-cloud Kubernetes, and a very simple solution, a SQL query built on a stack of very simple assumptions. And this tweet basically suggests put one on your resume, the other in production, and everyone goes home happy. And I'm sure we can all see which one we want to put in production and which one we want to put in the resume. So definitely data science is a very exciting field. And it is not necessarily complex. It is very challenging, but it's challenging in a good way and not necessarily complex. And with that, I would like to thank you all for being here today and would like to open it up for any questions.
That was an amazing session. Uh, Folks, please add your questions to the chat or feel free to unmute yourselves to ask the questions. For the certificates, you will be getting e-certificate if you have checked in for the weekend and hackathon. So make sure you check in for hack nights. So you will get the certification of that. There is a question from Ketan if you would like to take that up.
Okay. So Ketan, I think you're asking how do we keep track of new models, right? Is it something you would like to elaborate on the question or? So I can give, okay, I see your question now. So I think definitely, as I alluded to, it's definitely changing very fast. But I think a lot of models out there are not necessarily, uh, implemented in industry right away. Especially if you're in industry, it helps to keep track of new models, but it's not necessarily that they're going to be useful on day one. And I would say the best ways to keep track of new models would be to first of all identify your area of interest or specialization, right? Like if you want to keep track of all models in machine learning, I would say it's almost impossible. It's not feasible. But let's say you're specifically focused on natural language processing, or let's say you're focused on computer vision, or let's say you're focused on risk modeling. I think that's a more tractable problem where let's say you can follow people on social media where a lot of people publish their research. And I would say you can also keep up with conferences in the area. Like for example, if you're focused on like say computer vision, you can follow the latest papers that were published in CVPR every year, or let's say NIPS of every year. So there are a lot of very popular conferences that happen every year for machine learning, or ICML, International Conference for Machine Learning. So a lot of good research comes out in these conferences. And the other thing to do would definitely be to follow the researchers in the field. Like you can if you know who are the the most active publishers in the field, you can go to their like say their academia profiles or other profiles and see their latest publications. And even Google Scholar is a great resource. And lastly, I would add that one resource that I use is Medium. So on Medium, there are multiple AI channels. One example is Towards Data Science, which also has a lot of guest contributed articles on the latest and greatest in the field. So hopefully that answered your question. Yeah, I see.
There's one another question, two questions. So from Tayo, like for jobs, does personal project count, especially for someone who hasn't previously employed in data science related jobs?
Okay. Yeah, great question, Tayo. So I think definitely yes. It's like a chicken and egg problem, right? Like some jobs require professional experience, but if it's your first job, you won't have professional experience. So I think there's definitely some amount of the chicken and egg problem, but personal projects count a whole lot in data science. Like especially for junior data science roles or early career data science roles, personal projects actually have a very heavy weightage in the resume. So you would see a lot of resume templates also having like 20-30% of the resume actually dedicated to personal projects. But I think it's all about what project you choose and what like what is the impact you do in the project. But I would say, for example, when I was in grad school, almost like 80% of my class had either the Titanic data set or any of these other popular Kaggle competitions. So I think it's a very common thing to have the personal projects in your resume, and they definitely count. It would be even more helpful if it is public. And what I mean by that is, let's say you did some analysis somewhere in a notebook. It's probably less useful than, let's say, you are able to turn that analysis into like a web app or a consumer facing app. It could be very simple, but if you make it public, it counts more. And it also, for example, if you have like a GitHub profile where you show your discipline and continuously contributing code, etc., it helps your cause. Hopefully that answered your question. Yeah. I see Keshav had a question on a lot of times there's a lot of boilerplate code for data analysis and ML modeling. Is there a resource where we could find all these readily available? Hey, Keshav, I think my only answer to you right now is going to be ChatGPT. So especially if you want to, get your boilerplate code for data analysis and ML modeling, ChatGPT does a really good job. So especially in 2023, I think we are lucky to have ChatGPT with us. We don't have to go through like 20 resources to find boilerplate code. I mean, before it would have been like Stack Overflow, but now, ChatGPT definitely gives you like at least like 20-30% of the boilerplate code for you to get started quickly. Yeah. If you have not leveraged ChatGPT for, getting boilerplate code or starting your analysis, I think I would definitely strongly recommend you to do. And then I see AD has asked, what math do we need for data scientists? I think that's a very broad question. I'll try to distill it down. So I think definitely a foundation in applied math or statistics is definitely going to be helpful for data science. And what math? You'll see a lot of linear algebra being used, especially when you're dealing with neural networks. You'll have a lot of matrix multiplication, tensor multiplication, vectors, etc. So definitely helps to know a little bit of linear algebra. And one other algorithm, for example, would be like, say, support vector machines, where again you use a lot of like linear algebra, like, margin math, etc., to build the model itself. Again, I would say math is becoming a little less important right now compared to coding. I think before it was a lot more math and a little bit less of coding, but now I think it's a little bit less of math and more of coding. But I would say definitely a foundation and a little bit of statistics, hypothesis testing, and linear algebra would definitely help you stand out. And if you have like question about a specific type of math you're curious about, we can chat. Okay. And the other question I see from Ketan is, do you know any model for speech to text for my hackathon project? I don't recollect any top of mind, Ketan. Yeah, sorry about that. Yeah, I've seen some implementations of speech to text, but I don't really know any like particular name. But I think any sequence to sequence model you can be tuned to do like a speech to text application. And for speech especially, probably you're thinking of like an ASR approach. Like, let me know if that's kind of what you're thinking. So doing like an ASR and then transcribing the text would probably be the solution I can think of.
Amazing. I was really happy to see so many good questions coming in and interactions from the community members. Really glad everyone attended. I don't see any more questions. So thank you everyone for joining. Thank you, Natesh, for giving such a amazing session. And I hope the lot of attendees will get inspired for pursuing data science or like exploring more into the field and taking inspiration and knowledge from the session. Thank you everyone for joining.